Section 1.5 is on the volume of right pyramids and right cones. And you've done volume before in junior high. And these are some of the first, on the chart here, some of the first few formulas you should be familiar with. The volume of a rectangular prism is length times width times height. If that's a cube, then all the dimensions would be the same, so it would just be the side cubed, because the length, width, and height would be exactly the same. A triangular prism, you'd have the area of the triangular base times your height. A cylinder would have the area of the circular base times the height, so pi r squared times height. A square-based pyramid, we did a little demonstration in class with the cube that had the same base and height as a pyramid, square-based pyramid, had the same size base and height, and the volume of the square-based pyramid, if you remember, was the same as, it took 3 of those pyramids to fill up the cube. So the volume, that kind of leads to the formula of a volume of a square-based pyramid. And a square-based pyramid would be 1/3 the area of the base times the height. And the area of the base, of course, would be the area of a square times your height, and then divided by 3. The cone, again, similar demonstration in class. You could take the cone and fill it up. If you took a cone and a cylinder with the same base area and same height, it would take 3 cones to fill up that cylinder. So the volume of a cone is related to the volume of a cylinder, and the volume of a cylinder is your pi r squared times your height. So therefore, the volume of a cone will be pi r squared times your height divided by 3, or 1/3 pi r squared times height. And the volume of a sphere is a little bit harder to explain, so I'll just give you that formula. It's 4/3 pi r cubed. So we're going to do some examples with those. Okay, our first example is a little bit of review. And so the volume of a cylinder. Volume is equal to, for a cylinder, is the area of the base, which is pi r squared, because this is a circle, times the height. So we've got pi, and r is 12.0 squared, times the height is 8.1. So we do order of operations. We do our 12 squared first, times our pi, and then times our 8.1. And we get 3,664.35367 are the digits that come up on my calculator. So that's approximately, to the nearest tenth, would be 3,664.4 centimeters cubed if it's a volume measure. Okay, so now we go through the formulas again for the volume of a right pyramid, which would be the area of the base times the height divided by 3, or 1/3 area of the base times the height. And the volume of a right cylinder, right cone is related to the volume of a right cylinder, which is pi r squared times height. So you divide that by 3 and you get the volume of a right cone, or 1/3 pi r squared height if you prefer. So let's try to find the volume of the 2 examples here. So the first one is a square pyramid, a right square pyramid, because you can tell by the markings on the base here that it is a square, both of those sides. The dimensions are the same, which indicates that it's a square. So our volume would be area of the base times the height divided by 3, or 1/3 of it if you want. So this would be area of the base would be 9.4 by 9.4 times the height would be 12.4 divided by 3. Put that in my calculator, I get 365.213, so on. So that's about 365.2 centimeters cubed. Cubed because it's volume. So the volume of the cone, the volume of the cone would be related to the cylinder, which is pi r squared times height, but again it would be divided by 3, or 1/3 pi r squared times height. So pi r would be in this case 14.1 squared times the height is 22.6, and then divided by 3. So 14.1 squared times 22.6 times pi, and then divide that by 3. Get 4,705.1696. So if we round that off to the nearest tenth, it would be 4,705.2 centimeters cubed. Okay. All right, so we're going to try a few examples. Determine the volume of this pyramid. And again, it's not a square-based pyramid, but you still basically follow the same formula. So we have volume is equal to area of the base times the height divided by 3. So that would be, area of the base would be 30. Doesn't look like a 30. 30 times 35 times 15 divided by 3 times 30 times 35 times 15 divided by 3 is 5,250 yards cubed. Next one, a cake decorating bag is in the shape of a cone to the nearest cubic centimeter. How much frosting will fit in the bag if the diameter is 15 and the height is 25 centimeters? 15 centimeters and 25 centimeters. So again, we have a volume of a cone is pi r squared times the height, 1/3 of that, or divide that by 3. So we have pi says that the diameter is 15. So if the diameter equals 15, therefore the radius is 15 divided by 2, or 7.5. So we have 7.5 squared times the height is 25, given as 25, divided by 3. So this would be 7.5 squared times pi times 25, and then you got to divide that by 3. So that would be 1,472.621,556 comes up on the calculator, so if we round that off to the nearest unit, it would be approximately 1,473 cubic centimeters. Next question says a cone and a cylinder have the same height and the same base radius. If the volume of the cylinder is 81, what's the volume of the cone? Well, if they have the same base height, same height and same base radius, that would mean that the volume of the cone should be the volume of the cylinder divided by 3, which would be 27 centimeters cubed. Question number 4 involves rearranging and using algebra skills to solve for an unknown variable. So it says a cone has a volume of 30 centimeters cubed and a base area of 15. What's the height of the cone? So volume of a cone is pi r squared times height divided by 3. So we know that the answer is for the volume is 30. So we've got pi well, we don't even, it says the base area, so we don't even need to go pi times r squared, because we can just replace the base is going to be the circle part, so it's going to be 15 times the height, because the base is a circle, pi r squared, so we just know that we don't know the radius, but we do know that this base area, or the circle area, is 15, so we have 15 times height divided by 3. And then that gives us 30 equals 5h. So then 30 divided by 5 equals 5h divided by 5, which gives you 6. So therefore the height of the cone is 6 centimeters. Number 5, a cone has a height of 4 yards and a volume of 205 yards cubed. Determine the radius of the cone. So if we know the volume of a cone again is pi r squared times height divided by 3, and we know that this is 205, and we know that pi, we don't know what the radius is, that's what we're trying to find. We do know that the height is 4, and we have to divide by that by 3, and we get 205. So the first thing I'm going to do is I'm going to eliminate the fraction by multiplying both sides by 3. I'm going to multiply this side by 3. Those 3's are going to cancel. So that's going to give me 615 equals 4 pi r squared. And then I want to get the r squared by itself, so I'm going to divide both sides by the 4 pi. So 615 divided by 4 pi is 48.940. That's enough decimal places. So therefore r would equal the square root of that. Which is 6.9957, so on. So that would mean that the radius is approximately 7 yards. Next one, a rectangular pyramid's base has a length of 12 and a width of 5. The volume is 425 centimeters cubed. What is the height? So this would be, volume is area of base times the height divided by 3. So we know that the pyramid's area is volume is 425, and the area of the base would be 12 by 5 times the height over 3. So again, we triple both sides to get rid of the fraction, and we'll get those 3's will cancel, and that's going to give us 425 times 3, 1275. 1275 equals 12 times 5 is 60, h. So then if I want to get the h by itself, I have to divide both sides by 60, and that's going to give me 21.25. So therefore the height would be 21.25 centimeters. Okay, and that's it for section 1.5, and there's some questions there on pages 42 to 43 of your text, which you can try for practice.